Hello and welcome. I'm Bill Wake. Today we're working on an Elm interpreter, as we have been for several weeks now, and I think we're going to work on definitions and symbol tables today. We might have a little cleanup on the line number stuff, but I think we're ready to go on definitions. All right, so let's see where we are. Oh, sorry. So nice of them to auto start that for me. Okay. All right. So we said we would handle definitions next. All right. Okay, so we have a failing test. Let's see. Interpreter is string. I think we may have decided this wasn't really needed, but maybe we can do it. All right, so this is a little helper thing. Normally you don't print an expression, you print the value of an expression, but for our debugging purposes, I guess, if nothing else, it may be helpful to see this. And let's find if expressions. I'm going to get rid of this. Well, if expressions, let's go find if expression. Okay, evaluate an EQ, but it doesn't have a print. So the parent has the print, and it's a default print, or as string. So we need to override this method. I still lost it. There we go. Okay, kind of. Can I get back to if expression? No. All right. I'll lock that in. Okay, so override. Okay. Let's see. So our return value, we'll mostly take it from the test. And the first is condition. Yeah, let's see. Let's do if we want those quotes there. I guess that's coming from it. Let's do this. We'll take condition expression, so we'll do condition dot as string. And this is left as string. And this is right. This brace, I think, is extra. Oh, that's the condition. That's the whole thing. Okay. Let's see how that goes. It's a diversion. I got all psyched up to do the definition stuff today, but we'll finish this thought. Well, we'll try to finish this thought. What did we get instead? We don't have quotes. If true, bool number. Oh, yeah, that's true. It should be bool. If true of bool. Oh, I got an extra float in there, don't I? Well, supposed to be red, green. If true, colon, bool. 3 colon number. 2.5 colon float. Oh. I got 2 parentheses here. Golly. They tell you red, green, refactor, not red, 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 green, refactor. All right, commit this. Give if interpreter and as string method. All right, make sure I'm streaming and recording today for a change. All right. Okay, so I'm just going to close everything other than to do. And this is the 2021, not 2020. How many times will I do this wrong? Okay. And the story is handle definition, so let's put that in there for what we're doing. And the challenge we have, so a definition is something like x equals 3, and then somewhere else later on we're going to say x, and we expect x to be treated as 3. In a pure functional language or is pure the right word? Well, referential transparency is the word that comes to my mind, or the phrase that comes to mind. If you can always just kind of substitute things in for equal things, then your life is much simpler. If you have variables that change and values that change and things like that, then your life gets harder and uglier. All right, so we would like to handle x equals 3. And the way I want to start is with what's called a preparatory refactoring. So let's look at our expressions again. Actually, we'll take interpreter, expression, integer value. That should be enough. And we started a definition, but we haven't done anything with it really. Okay. Oh shoot. I don't know if we even need interpreter. Integer value. Okay. So in the case of the integer value, so if I just type 42 and I want to evaluate that, it really is just the thing, just the value I have. I hold on to 42 and I tell you, you want my value? 42. Okay. And so evaluate is just return self. Now in principle, evaluate is, it's left to the definition of the subclasses basically. But if I imagine evaluating X, so, I guess maybe this is a variable. I don't know the right phrase for what we'll call it, but maybe it's a variable and we want to evaluate X. X doesn't know. I mean, this node has no way of knowing what X should return. It doesn't know if we said X equals 3 or X equals 4 or X equals square root of n. It just doesn't know. And so that tells us we need something else coming in, some other information to give us the ability to evaluate that. And in the design patterns book, this guy, then the interpreter pattern, basically, they say pass in a context for evaluation. Another word for context or phrase is SymbolTable. Basically, we're passing in the definitions that we already have. So if we've defined x equals 3 and you evaluate x says, hey, I'm going to look up my value in this SymbolTable and I get back 3 and say, okay, cool, I will return 3. Now, that's good, all right, but we don't do that yet. We don't pass anything in to evaluate. And so I have a design I'm shooting for, which is the interpreter pattern with passing in a context or SymbolTable. And I don't have that design in place yet. Now, one way would be we can go in and go down the path with variables and references. Hey, Q coding, nice to see you here. Go down the path with variables and references, and eventually we'd be surprised and shocked, right? Hey, here's an X, and I don't have the information I need to evaluate it. So this notion of preparatory refactoring is to say I'm going to put a design in place where when I go to make my changes, it becomes much easier. All right, and so normally, like if you refactor and you get rid of dead code and things like that, we're going to take a step and we're going to pass a parameter in that nobody wants, the symbol table or the context. I don't know which way to phrase it. I think I'll stick with symbol table, but we'll pass in the symbol table. No one's going to reference it. It's dead code. We could delete it and not change the behavior of our system, but we're doing a preparatory refactoring. We're putting that in place so that when it's time to evaluate, we can say, hey, please evaluate this thing. We aren't surprised. It's easy. Okay. Yeah, prefactoring. You hear that sometimes. I know Martin Fowler has a nice article on like workflows of refactoring, and he lays out 5 or 6 different ones. A lot of them are similar, that they're kind of improving design. This prefactoring or preparatory refactoring, as he calls it, it's different because we're kind of going the other way. We're speculating about design, even though we talk about don't do speculative generality and all these things. But sometimes it's just easier if you have your design structured in a way that makes it easy to do things. And so that's what we'll do. Okay, so right now we don't have a SymbolTable class at all, and I'm not sure whether, like so many of these things, it's kind of hard to tell whether it belongs on the parser side or the interpreter side, because our interpreter side is really the nodes that we're interpreting, and the parser produces those. So we're going to kind of wish something into existence, pass it all around, and not add a lot of functionality to it just yet. It will come, but I'm just trying to get the objects pushed into a shape that I can do that evaluation and have some chance. Like I got a symbol table coming in, I can do it. Okay, so let's just add the class. It feels so weird to me even still, just like, oh, I'll just go add some code. But that's what we're doing. It's not a ton. All right, so we'll call it symbol table, which is good parser terminology, or compiler terminology. All right, and this is just a public class symbol table. Good guess. And I'm not going to put anything in there right now. I'm just trying to bend the shape around, and then I'll go in and do more proper. Well, this is proper TDD, but I'll do more typical TDD, red, green, refactor kind of stuff to get the symbol table working. Okay, so I'm affecting the structure of my nodes and all that stuff, but not the rest. Okay, so and our choice is to do this on evaluate. So what I'm going to do, I have to change all these things, and I don't see an easy way. Everybody wants to use evaluate, and that's just the way it's going to be. All these things is like 5, so I'm not completely broken the whole time, but let's give a symbol. Let's see. Maybe I should call it context in here, and it's a type symbol table. Is that helpful? It's the context of the evaluation. Okay, now if I build, I get a bunch of broken subclasses because everybody's supposed to have one of these things. Okay. And evaluates. Yeah, that's fair enough. Okay. So evaluate a context. If expression. Where's float value? Evaluate. I don't know where the rest are. What's wrong with you folks? You should be complaining. Empty expression, does it evaluate? No. Error expression does not evaluate. Custom value does. If expression. Okay, here I'm I'm going to evaluate things in this context. An if statement doesn't change the context. Okay, so that's fine to just pass it through. All right, and definition, I don't think, yeah. Okay, now I should just get people, expression I should have got. Sorry, interpreter. Failed. Tell me where it is. Okay. Okay, so I'm going to say when you interpret, you need to give it a context as well as an expression. Let's see, context of type SymbolTable, and we'll pass that down. Okay, now we're getting to the callers. The caller of interpret is probably just tests. We may have some callers we don't have. Build succeeded. Now run tests. Yeah. Okay. Evaluate context declared here. Missing argument. Okay. Let's just declare empty ones for now. One left? No? Okay, that wasn't too horrible. Okay, so I'll commit this. So we, it was a refactoring, yes, preparatory. Let's see, so we created a symbol table and passed it through to all evaluate calls. All right. Yeah, so the reason we can get by with an empty declaration here, well, nobody's looking at it anyway. That's one reason. The other is we're not doing anything. Well, maybe true. We'll have to do some resolution around the Boolean stuff, but to evaluate the numbers, you don't really need a symbol table. And if it's empty, you don't care because you're not referencing symbols. And as of now, we don't have anything that does reference a symbol, so it can't get caught. All right. Now, okay, let's see. Yeah, Q coding saying, you can do this with two methods. So we could have added an extra evaluate method that took the parameter. So we had two methods, one evaluate with one parameter, one with 0. Do the children first, get them all right, and then require it in the parent level expression, get that all right, and then cut it out, get rid of the empty one that you don't use anymore. Yeah, I mean, a 5-minute diversion, I'm okay. But if this were, if we'd come in later when we had 25 nodes and, 500 more tests and all that stuff, we wouldn't want to have all the parts laying on the floor while we're doing that. Yeah. All right. And, I have to say, this is one of these places where I miss the IntelliJ and Eclipse and some of the other tools that have a refactoring that's like add an extra argument and you can just set the default value for it and all that. Would have turned it into kind of a, not quite one keystroke, but one interaction. I know you use AppCode. Does that support that introduce parameter or adding that parameter to the subclasses directly? All right. Let's see. Take a peek over here. Okay. So now I think, let's see. We started talking last time. We talked about define, and it's complicated. So this example was what I had, that there's sort of the notion of the system level definitions, and we haven't quite worked out exactly how we're going to get that injected in the right place. I'm not even quite sure. Elm, like somewhere I saw it having files that it used to get Boolean and false and true and all that stuff defined. I don't know if that was just sort of a is the actual way they define it for their methods, but but uh, we'll work something out. Okay, app code has change signature but can't infer the value. Okay, yeah, that's too bad, but I would kind of accept that, because if I had 50 syntax errors but they all were just like paste in symbol table parentheses, not so bad. Okay, so back to the definition. So I'm assuming we need some sort of nested symbol table, and from a client side, we don't care just yet. Um, but oh yeah, nice. But what we're going to have to do is, like, we'll have a top level definitions that start out empty, and they kind of chain. It's like there's a chain of responsibility pattern that you, to look up something, you go to the first thing, and if it has it, it gives it to you. Otherwise, it defers it to the next thing, and on up the tree, or at least you can use it that way. That's the kind of symbol table we're going to need in the long run, because the system table stays the same for everybody. But if we do a lambda expression, well, this is sort of an implicit lambda. This n is in kind of a new context. It's not the n if we had a top level n. Okay. And so I'm assuming after you say x equals 3, you've got x maps to 3 in your symbol table somehow. And when you go and ask for x, you get 3. All right. And I don't know, it's kind of a toss-up. Well, again, this is just going to be the, I don't know. It's not Wacky Wednesday, so it's Wacky Tuesday, I guess. Not as alliterative. The deal is it's like, what are we going to do to derive this into place? I kind of know what I need. And so I want to get some stuff in my symbol table and have that there in place before I worry about definitions. So there's kind of like two things. Well, there's several things, but one thing that happens is you say x equals 3, you make a definition, and we need to insert x into the symbol table with its definition. Another thing that can happen is you reference x. Hey, x, what are you? I'm 3. And a third thing that can happen is you introduce a new context. That's kind of like that square root n case. The expression n squared is in a context that's whatever is out there in system land, well, in other definitions that are existing, but it creates a new context for definition where it's got its own n. And when we go out of this context, square root of n equals n squared, we don't want to keep track of that n anymore. It's not our worry. It's only defined in the local context. So entering a context and exiting a context are two other things that happen. They're definitely the advanced ones, but I think it's clear we need to say insert this definition in our symbol table, and we need to be able to say look it up and get the definition. All right, so let's do that as a little mini project, I guess. It's part of this definition thing, but I'm going to close all these again. I'm getting too buried. Let's find symbol table. Okay, pretty empty, and let's put in a symbol table tests. All right, switch file. I've got Q coding here. I keep saying I'm going to get his templates and get them installed and start using them, but now I have to be embarrassed about it. Okay, so let's add symbol table tests. And I saw he just updated them like a week or two ago. And okay, my poor approach at this point. I usually just come and grab the front of these tests because it's faster than dealing with Apple's template. Okay. and symbol table tests. All right. So I'm going to just put in the two things I want to happen, and a minimal implementation will make that work, and we'll go with it. So let's see. So the first test is, I guess, putting a definition in. Maybe it's both. I guess we put it in. We got to be able to look it up. So define. Well, let's see. How about defined value is found? All right. And so we're going to create a symbol table. I guess it's a var is probably more appropriate. Equals symbol. Well, I guess it doesn't even need, maybe it should be let. All right. And I'm going to do table.add, and let's do X, and it's got a definition of 3. What's the right thing here? Maybe it should be an expression. The X is probably okay. I want to say this is probably an expression. So let's do integer value. I think we can do that. All right. Because the result, the stuff we're putting in our Elm type number, the things we're putting in our symbol table, we just parsed it. X equals 3. Well, 3 is not the string 3. It's an expression we just parsed, the integer value 3 with Elm type number, and we definitely want to see it back. All right, and then let's assert equal. So if we do table dot, can I do sub X, and I expect back, and well, I expect back this integer value. Okay, and my pause there is, should I be putting this in? And I guess so. Okay. Let's see. So symbol table. Let's go there. We're saying we need a function add, and it takes a string, and it takes an expression. It's void. Okay, so I'm just stubbing things out. And I don't know if I've ever defined my own bracket operator. I assume I can. Wow. Well, let's look for operators. Unless you just know what I say, I'm happy to do that. Oh, I saw the other one said, assume we have a vector. That sounds promising. No, I just want a bracket operator. Maybe I just say that. Let me try that. Well, let's take something that is one. Array, I guess, right? The one time they've got all these examples. All right. Selecting elements. Oh, subscript. Yeah. Okay, I've done that before. Do I just say subscript? Oh, thanks. Subscript index entity. I'm hoping I can use other subscripts. Let's try this. Yeah. Okay. Oh, must have accessors. What does that mean? I'm going to return nil just to get through the test. So I'm trying for my red test. I want to fail. Should have no trouble with that. Found a nil while unwrapping an optional value. Okay. Yeah, okay, I don't need all that. So what we're seeing is this thing is not, we just hard-coded nil and you access nil and you do a bang on it, then you're going to get an exception or, a runtime error. All right. And I guess I'm kind of keeping in my head too many things here. Okay, so one is get SymbolTable working. All right. And then the other is I'm just going to stack up a couple more tests. One is symbol not found, and I really do make a stack here. So we're working on simple access, but we also have symbol not found. And I don't know if we'll do this one, but we also have symbol in a different context. Maybe it's an outer context. Okay, so we're working here. Next on the stack is this, and then maybe we'll do this, and that's all kind of part of get SymbolTable working, which is part of that. Okay. Let's see. So SymbolTable tests, and I'm just going to use a simple map here. Okay, so var table of type it's name string to expression. Okay, practically built in. Okay, and I can do that for starters. Always looks a little weird. Yeah, I mean subscript for string is handy. Symbol expression that. Okay, so we want to make this thing pass. So I guess I'll call that a red when it crashes like that. I'll allow myself that. So we're just going to put table sub name equals expression. Makes me wonder if I should be doing that too, but I will pass. And then we'll return table sub name, which I think already returns that right type. All right, let's see. So I got a symbol table, which is a map. I stick something in, I take it out. Seems reasonable. Expecting green. I should say that. All right, and let's add that error to case just to make sure we're not making up values. Undefined value returns nil. Okay, and we don't have to put anything in to assert it's not there. Yeah, you can assert nil. I don't know if that's better or not. I've gone back and forth on that a little bit, I guess. All right, and this is probably going to pass. It's more confirming. So I sometimes break out confirmatory tests, that I expect them to pass as kind of a side effect of the implementation I've already done. And this is one of those. All right, so let's get this on our to-do. So this is part of our story. We did symbol access and symbol not found. And I don't know, these are kind of inside there. Symbol in and outer context. I don't think we need this just yet. I'm going to push it off, maybe even after we get our stuff done there. Okay. But, I guess we're ready to do a definition and see what happens. So let's go back out here. And I know I started something with definition. I just stubbed it in. Okay, so a definition is name equals expression. No coincidence there. And we're going to do some tests on it. Okay, so I guess I'll take from here again. And this is definition tests. All right. Now, the thing is, what is the return value? Where are we doing this? This is kind of a challenge. All right, so this definition. This may not be an interpreter thing at all. At this point, I mean, we need to parse those things. We're still parsing all kind of up here. I've got the parsing of it. Okay. So what we've done, we already do parse it. We would just return definition, and I guess evaluate it is going to be given a symbol table, and it should update the symbol table. So we've got it parsing. So when you say x equals 3, we handle it. We don't handle square root of n equals n squared yet. We don't take arguments, but we do handle the simple case. And we create a definition node. So when you call definition.evaluate, we expect the symbol table to update. So let's table, well, I'll say symbol table equals symbol table. So we'll create a new one. And let's check what's the assertion we expect. I think the assertion is we expect, whoops. Oh, come on. I'm in a test, right? XCT assert. What? I import XCT test. What's going wrong? Sorry, definition test. Okay, what I want to assert is symbol table sub x is now equal to 3. I have to do it the hard way when it's not thinking right. Okay, so I put it in. I expect. Oh, yeah, okay. It's on me. So our test is defining value, puts it in symbol table. Whoops. Okay. So when you finish this thing, you look in symbol table, you should see 3 Elm type of number. Oh, thank you. I'll get there. Okay, so symbol table, and what we're going to do is we're going to call symbol table, maybe I should say evaluating definition. How's that? puts it in SymbolTable. SymbolTable, whoops, definition the name is X. I'm going to mix it up at least a little bit here. And I don't know, I'm using two separate instances just to kind of make sure we're not carrying something over, I guess. Okay. If we evaluate this with SymbolTable, here's what we expect. Okay. This is okay. And I don't know what it returns. That's kind of an interesting. We'll have to think on that one. All right, but I mean, the thinking on it is what we're doing here. I mean, that's really the goal. So, okay. Yeah, it failed. We didn't put anything in because it doesn't do anything at all right now. I think it calls error expression. And so we don't get the value out, failing as we expect. All right, so where's definition? And he needs the evaluate from expression. With the context. Okay. I kind of despise having to put that in there and tell it. Okay, so the value is, I think do we have an empty? Yeah, we'll return one of these, I think. All right, but the side effect is what we care about. And the side effect should be context.add name and expression. Okay. And is there anything else I want here? I think that looks okay. I mean, it's pretty minimal. And that's a good sign. If everybody's doing their job, most of them have pretty easy jobs. Nice. Okay. I think we've done that. Let's assert that the result is empty expression. Okay. So I'm saying there's no real value coming back. We don't care about it. We'll see. In real life, I mean, as we get more realistic, it may matter more, but I don't think we need it for our purposes. So let's run this. And I think this, again, I'm confirming something I already pretty much believe, but all right. So we added evaluate to definition. Cool. All right. Normally I take a break by now, so we're a few minutes over. We'll just take 2 or 3 minutes just for a quick break, and we'll come back, and we've done one side of this, x equals 3. Now we need to do an evaluate side, and that'll introduce some interesting issues on the parsing side. But just 2 minutes, and I'll be right back. See you in a bit. Hi, welcome back. All right, so we're ready to move on. Let's go back to to-do. Interpreter with SymbolTable and context. That's sort of what this is. I'll say passed in to evaluate. Okay. And so we've handled this definition. I think that's all we're saying for now. If you say x equals some simple value, there's nothing else. I mean, really all you have is true, false, ints, floats right now. Okay. So now the story is evaluate a variable. Eable. Okay. And so like x. I don't know if that's helpful. Okay, so definition, I don't think we need. Empty expression, symbol table. Okay. So the story is evaluate a variable. With a previous definition. Okay. So let's take a look. Let's see our parsing, I guess. And we'll need parser tests. Okay. Oh, I wish I could make that just work. But I always had to click it myself, as far as I know. Okay. So yeah, name equals expression. So let's go up with this thing. We're doing recursive descent parsing. So basically every grammar rule turns into a function. So here's the expression function. Here's if statement and so on. Here's our definition we just finished. But now the thing is, this is tricky. So if you reference name, so when I'm thinking about these things, let's see. Can you explain your to-do list? Let me go back and do that. So it's kind of two stacks, I guess, is really what it is. So I'm working on the current thing, evaluate a variable, and then I go down and say the next thing I expect to work on is symbol in an outer context, and we I don't even really have a proper story named for that, but if I have a task, well, evaluate a variable. We know there's two tasks. We got to parse it, and then evaluate. And so I'm saying I'm working on parsing. Next thing I expect to work on is evaluate, and that's all part of evaluate a variable. I might have more tasks come in, and then this is the next task down and the next task down. And then when I finish it, I just go most recent first and put something in there. So I don't do it every test case level. I tend to do it at stories. Stories certainly show up on the stack, and kind of high level tasks like these. If I got diverted to something else, I would stack that as well. And I'm terrible at it as far as like keeping it up to date. I forget all the time, but it is how I try to use it. Okay. So the deal is in our parser, and I'm just going to move this one first. Here's definition. So we have an ambiguity. So this is why I'm feeling stuck. So when I see X, I don't know if you are planning to call that the expression you're evaluating, or are you about to create a definition? And I think oh boy, there may be something going on here. Let me bring up the Elm interpreter. I think Elm REPL. Oops. Okay. So if I say x equals 3 and I say x, we return the value. Interesting. But I say x at that point. If I think of it in parser terms, I'm going to go along from the start, from the greater than sign is the input prompt, but my string I typed was x, And I see the X. Am I about to evaluate this or am I going to define it? And I think the only way I know right now, I don't know. Because like you have this square root n equals n squared thing, right? I could see X and a name. I guess that wouldn't make sense from an evaluation point of view. So if I see, so how am I going to distinguish them is the question. I think what I'm going to say is if I see X followed by what? If it's followed by, well, maybe this is just like X plus 2. If I can get by with treating equals as an operator. I know if I see square root or square, let me do this. If I do square of n, right, square is definitely not a value to evaluate. I'm doing a function definition. I don't know what happens if I just do that. Okay. What are you trying to do? Okay. Oh, were you trying to do square root of n or something? No. But if I do square root of n equals, it says, I know you need more, right? Because you need to say what, well, I'll cancel that because I keep saying square root. Square n equals n squared. Oh, okay. Extra line needed. And he returns function. Oh, interesting. So the value in the interpreter, the value just returns the value if it's a simple value, and the function if it's a function. All right, but my where I'm going is if I see a variable followed by equals, I know it's a definition. If I see it followed, a name followed by another name, I know it's a definition as well. And if I don't see that, yeah, if I don't see either one, I guess I'm going to assume it's part of an expression to evaluate. That seems plausible. Okay, so if I see a lowercase name, it's not necessarily a definition. So when I go to parse an expression, I'm going to say I'm going to rename it, but I'm going to rename it to I'm going to say variable expression. Expression. Okay. And kind of broaden the way it's done. The other thing I was looking at is it would be nice if I could say if the variable happens to be undefined, then obviously we're defining it. And if it's defined, obviously we're using it. But when I go in Elm REPL, it doesn't really work that way. So let's do y equals 42 and then print y. You can do that, of course, but I'm allowed to redefine it here, which is weird. Now, what I don't know is if I say, let's say foo of n equals y times 3, or y plus n. Okay, if I say foo of 3, that should be 21 plus 3, 24. Okay, what if I redefine y equals 2? Okay, and now I evaluate foo of 3. It's 5. Okay, so what that tells me is my evaluation context is not fixed. It doesn't just look up y here and say, oh, y, that thing has the value 21. It's evaluating that at runtime or evaluation time of foo, which is good in a way. But I also feel like, and I haven't brought up the language again to double check, but I feel like if you did this kind of thing, y equals 42, y equals 21, in an actual Elm file, I'm not sure it's as forgiving as that. but I guess I don't have a choice right now. Okay, so let's see. So the grammar of this thing, uh, it's kind of multiple choices. So one is just name plus equals expression. That's a function definition. This is more of a constant definition, although constant's a little bit funny. But I also could just have name, and that's a reference. Now we haven't done this one yet. Line 105. We haven't allowed for that at all. Okay. I'm gonna put it on the bottom and use one of my rare to-do cards. All right. So name plus equals name plus is one or more instances of. Now, I don't know there may be other function forms we can use to define things. I'm not an Elm expert yet at all. So all right. So I think we're gonna want to change the evaluation of this. So if we saw a token by itself, then that's this case. Basically anything other than name equals for now. So let's define some parsing for this. So where's definition? All right. And this file, it's starting to get big, and we're not even halfway through the grammar yet. So I don't know. We may need to break this out. It's parsing is we're using a very old school technique. I mean, recursive descent has been around for a long time, probably since the 60s and maybe earlier. All right, so let's just test variable reference. Okay, and for now, yeah, so I think if we check successful parse of X, we should get a variable X. Doesn't exist yet. Okay. And we're not evaluating it yet. We're just making a reference to it. Okay, so so here I'm going to stack up this. So let's put in the variable. Man, I'm going to learn to spell that word today. Variable type. It's kind of a subtask. All right, so the variable type. It's really just it's a node like these. So let's go ahead and create one. All right, and this variable. Okay. And it's going to be very similar to this. We're going to initialize it with the variables, the string. Okay, but let's put in a test for it. First try. Okay. Grab that line this time. Okay, tests. This is variable. There goes my run. Close the function, close the class. All right, and we're going to test variable able name is stored. Kind of a simple one. Okay. I don't know what we do to pull out the value. Huh. Well, I guess we'll get to evaluate, but let me just pull up integer value again. I don't think I'm providing anything to get to the actual stuff, am I? Okay, interesting. Like, how am I going to test this thing? I guess I just have to check that it equals itself, or one variable of a string equals itself and one of a different string doesn't, I guess. Test the equality. Okay, so variable tests. Well, how about variable with same, let's just test equality. Okay, and I got this pattern from Jim Shore, which is basically like let variable 1 equal variable of name, and variable 2, well, let's see, you can do 1a and 1b, and variable 2 different. My I key seems to be sticking lately. Not good. Okay. We want a variable to take arguments, and then our tests, we're going to assert equal variable 1a and variable 1b. Whoops. 1b. And assert not equal 1a and variable 2. Okay. And we have variable here. We've got to give it an argument. Init name of string. Okay, and test should fail. Well, I didn't mean completely fail. Expression. Now that comes with some obligations. Let's see if it'll. Superclass is internal. Am I messing up my public? It should. Okay. A type. I'm not sure what's suitable at this point. Dot. Let's. Ooh. I think we need an unknown is what it's going to come down to. And let's go over there. And if you return unknown, whoops. It should still be complaining about, like, I need an EQ or something like that. Yeah. Variable conforms to equatable. We're going to use unknown in here. Let's find integer value. Expression. Why is that not? I don't know why it doesn't conform to equatable already. Let's go up to expression. Expression is equatable. Maybe I'm not. I will clean and try and run. I don't know. Xcode is just flaky enough. You hate to blame the tool, but I've had too many times where rebuilding wakes it up and it starts parsing correctly internally. Okay, that's a correct failure, but we were after a different one. Okay, whelm variable is not equal to whelm variable. All right, that's kind of what I was expecting. We'll get this one test working first and then go on to the others. And the way we do this is basically this kind of expression. We've got our own EQ defined for subclasses, so you can compare them. And so we'll have to compare other as variable and self dot. I've got to store the name. Let name of type string. And then we do this before. Okay. So the other variable and matches the name and the type matches the type. And I think we'll pass now on this one. The original test is so bad. All right, so that test is green. The one that started this stack was this one. All right. Variable is not equal to error expression. So what are we saying? Oh, yeah, we get an error expression because we don't parse it. I did shift command K is force clean. And I don't know, it just seems often, not often, but probably 1 out of 6 times or something, when I get that kind of stuff going on where the types aren't lining up, it's either, maybe it's just too slow, to kind of mark the syntax errors, or maybe it's just lost its little mind, I guess. All right. So parse. Yeah, now our parse, we're back to our parse. And let's see our parser. So we require an equals and we don't get it. So we say this is a failed expression, return error expression. Okay. Oh, and I see, last time and maybe the time before we worked on error messages for our errors in tokenizing. We hadn't done it for the error expression. So I'm going to put that on the to-do list too. Probably before the context stuff. We need to handle, provide error messages for parsing errors. We do Lex errors already. Okay. And now back to our parser. All right. So if I see an equals, yeah, so if the token is an equals, then I definitely want to do this stuff. So instead of requiring the equals, I'm going to say if the token is token equals, I'm going to do some stuff. I'm going to do all this stuff. And then for the moment, I'll just say return error expression. Okay. So I think I'm trying to make a refactoring out of this. Try require, we'll do a lexer.get, but we can also do the same thing. And we know it's an equals, so I'm going to do lexer.get. All right, so the convention for the recursive descent approach is that you always start with the first token already in place, and whenever you consume it, you reload the next token, so it's ready to go. So I saw the uppercase, saw the name. Okay, I'm capturing it here, and I skip over the name now, and now I'm going to look for the equals, and if I see it, I'm going to say, okay, I got it, skip over it. I don't need this anymore, okay, because it's not going to happen. Let's do this. Whoops, did that work? Yes, okay. If I see an equals, I get it out of the way, grab the expression, and then make a definition, otherwise return error expression. Well, my error expression is really let's see, how do I want to say it? The error expression is the place where I'm going to put my variable. I'm just going to run this, make sure we still have one failing test. It's a refactoring, although a little weird. Ooh, I didn't call token equals. Okay. Let's try that again with one correction there. All right, so it failed twice, probably once on the definition case. Right, now we're at one failure, and it's the variable reference case. Okay, so now if you trace where we are, if the token is lowercase name, token equals expression, that's this case. The second case is we just saw token name, we don't see an equals after it. Oh, well, that must be a variable. Oh, come on. All right. How about you prioritize my definitions? Okay. So variable, and we pass in name. All right. Now, I think this is fine, except for that extra catch there. But from a pass your test thing, I think we're green, I hope. I intend to be. Yes. Okay. So now, because I'm no longer throwing an error if you don't have an equals, either path works. You know you have a variable, or sorry, you know you have a name. And so either you're going to say it's a reference, you know, a use, or you're going to say it's a definition, and there's no error path out of there. So I don't need this do anymore, and I don't need the catch, and I don't need the extra error expression. All right, and I'll just retab just in case. All right, and rerun. Oh no. Missing return. Okay. If lowercase name token. Now, in reality, I don't think this can fail, but I can, because if we get a lowercase, we're going to get, we wouldn't call this method unless we knew it was coming in with a lowercase name token. Let's see if we go up to the top. So parse sees a lowercase name. It knows the token is a lowercase name, so it calls variable expression. There's no harm if we just return error expression. But the reality is that if case let, I don't think it can fail the way we coded it. There's probably, I don't know the twiddly details of if case let and all those things. There's probably a way I can just force that. What if I just say let lowercase name, oh gosh, lowercase name of name equal token. Can I do that? I can do let name equal lowercase token dot. No, I don't know. Are you still in there, John? Do you know if there's a way I can just force this thing to give me the name, kind of like an as exclamation point thing? But let's make sure tests are green and let's get this checked in. Okay. All right. So handle variable expression. And so to do guard case, it does fatal error. Yeah, except I don't believe a fatal error is possible even. So I just, because I know I'm coming in with the right token, I would just like to say, give me the name field off this token. I know it's legit. But I'll save that. I'm okay to let that go for now. But I've mentioned before that like the actual parsing is pretty simple, but once you start mixing in the semantics and the error handling, these methods get a bit longer. They correspond to the grammar, so they're nice in that sense, but you do have to do some tracking through. But tracking that name, like I don't care at this point. I really could just call elixir.get and then elixir equals and so on. Yeah. If I just had to do those, I didn't have to keep track of the name. That would simplify things. If I didn't have to worry about errors, just let errors happen. Again, that would simplify it. So adding in semantics and error handling often doubles the size of these methods. It's just the price of it, I guess. The other thing is at some point, I don't know, 130 lines it's not the longest class I've ever seen, but it's getting a little long. But breaking it up, I don't know, it doesn't really add much either. It's hard for me to say what the right breakdown is there. In the end, this is going to be 500 lines, something like that. I don't know. All right, so where do we go on here? So to do variable type, we've got that. We parse a variable. Now we want to evaluate it. All right. So variable and variable tests. Let's put those together. All right. And so wake up. All right. So variable, right now we just have EQ, but I would like to call evaluate. Okay. So function test variable evaluates to defined value. Okay. Excuse me. So let's let SymbolTable equals a new SymbolTable, and we're going to add to it x gets the value. Let's do a float just for variety's sake. Value 425 elm type dot float. Okay, and then down here my assertion is I expect to get back put it on the right here. Float value 425 elm type dot float, and this is we'll let a variable x, and we want to do x dot evaluate with that SymbolTable. Okay. Some quotes would be good. And then I could actually evaluate variable instead of x here. Might be good. Okay. All right, so we put x in the symbol table. We reference the variable x. We say, hey, evaluate it with the symbol table for context. You should get back the value of x. And this should fail because today evaluate returns an error expression. Okay, one failure, yes. Let's see it down here. All right, and we got error expression, right. Okay, so let's evaluate. And again, integer value is probably a good model. Oh no, it's not. Well, I can borrow the prototype anyway. Variable has override function evaluate. All right, and now we need to look up the value in the symbol table and evaluate that result. Okay, so if let's see, so let's take context sub name dot evaluate with context. Okay. I'm gonna do this for now, and we'll make a different test in a moment. All right, but I expect this should make this test pass. Now you could have just looked it up and returned it, but that wouldn't really be right, because if I had y equals 2, x equals y, x. So, yay. Okay, let's put that in the, let's do z equals 2, w equals z. That's very hard to read, isn't it? Sorry. And I evaluate w. I should get 2. Okay, so here, interesting that it can evaluate that. Well, I guess it can. It can evaluate it right then. See, we may know the types at this point. It may be, we may be a little weak. Okay, but the other test is what happens if context doesn't know name. Okay, so if I just say Fubaz, some made up name. Okay, it's like, well, I don't know what that, I don't have that variable. Okay, so let's find our variable in our tests. Okay, unknown variable returns an error. All right, and we don't need the symbol table anymore. We'll just borrow this. We'll do variable Bob, and if we evaluate that, I think we have an error expression. Okay. Cannot find symbol table. We'll just make an empty one, because we know then that it doesn't have anything in there. So Bob is a variable. We try and reference it, but it's not in the symbol table. We expect to get an error expression. I think instead we blow up. Okay. So if dot, oh, interesting. We don't have a, well, I guess we got this. If context of name equals nil, maybe this is even a guard. If context is name equals nil, Then we're going to return an error expression. If let guard. Thanks. Context of. Oh. Oh, I sent you reversing. I thought I could do a guard clause the other way around. Let's see if I can find one real quick. Yeah, guard this. I hate to have to use else. Is it like that? You can see how much I don't even know the Swift basic syntax. I know I've used it. No, apparently I haven't. Okay. Let's do a quick lookup, I guess. Swift guard clause. Guard this, else the error. Okay, I just never think that way. And I kind of am a one-liner on this sort of thing. But I gotta get my directions right. Okay, if it's got to be not nil, and if it is, nil, well, maybe what you were saying might be a better way to just say it. If context of name equals nil, then do this. Okay, I think this is good enough for what I want. If the name is nil, we don't have a value return error expression. You can see our error messages are really weak here. Like, you had an error. Okay, thanks for looking up on that and suggesting, John. So if context name is nil, return error. Otherwise, evaluate it. That's exactly what we want. Okay, let's see. So I think that's a good place for now. Yeah, that would definitely be another way to do it. That might be better. So context name is giving us an expression. Is context of name. I would really like to have it flip this automatically, huh? I'm kind of okay like this too. If the expression is context of name, return expression, to your point. Expression. If return expression, I don't need this. Evaluate. That. Okay, I think I'm caught up. Yeah, I think that's an improvement. All right, so we've handled variable references. Okay. Yeah. All right. I'm just going to grab a quick drink, like a very, very short break. I'll be right back, and we'll move on. We're making progress today. All right, welcome back. Code Wrangler, thank you for that info on the custom operator. I missed that you were both talking at that moment. That's good. Appreciate it. All right, so we have variables. Let's see. Let's go to our to-dos. Evaluate. I guess I can say it here. And that's done. All right. So I'm going to look, let's see, let's go back to elmlang.org. We haven't been there today. And in the docs, there's a syntax examples. Let's see how we're doing against things. I think it maybe definitions are more, we might want to do the rest of definitions, but no, there was another one. Was it docs? Yeah, syntax. Okay, we handle comments. We handle literals, Boolean numbers, but not characters or strings. That's okay. We don't do lists yet. We do conditionals. I think we're done with conditionals. We don't do cases. We don't do records. We don't do functions. Don't do a lot of things. Anonymous functions. Basically, we don't do lambdas. That's another expression. Interesting. We don't do lets. Lets is a good place where we can see that we don't have the stacked up symbol table. Yeah. We do custom values. Well, custom types with these values and no ports. Okay, so maybe definitions is the place to go, because I think we definitely need to handle these kind of things, square n equals n squared, or multiple ones. And even they have this pattern matchy stuff. We've never seen that anywhere. I don't know if that's an explicit tuple as Swift uses it, or if it's more of a pattern matching. I guess it looks very tuple-like, doesn't it? Value AB. They didn't mention tuples up here. But we definitely have a pattern for it. Okay. It's going to make some challenges in the grammar. We're going to have to make that work, and it's also creating challenges in the way our symbol table manages. So I think we can show it's broken if we do square n equals n squared, and foo n equals n plus n. Well, actually, we don't have operators yet, but the equivalent of that, if you could say if true, then n, else something else 2 or something. But two different values with n, the symbol table needs to go back to the previous one when it's evaluating that or doing that. And I don't know, there's a tangle in there between the expression and the symbol table. I don't know. I'm not quite sure how that's going to work. I mean, I really am not. It seems like it may be that during parsing, we have to update. I don't know. We'll have to update the symbol table. Can you evaluate the symbol table strictly at interpretation time is my question. And I don't know. Now, the other thing we haven't dealt with at all is you can define types on your functions as well. Let's see. I don't even see any type declarations. Okay, here we go. Type annotations. So factorial goes int to int. Factorial n is that. I think Elm will infer them for you if you don't. But we we have some gaps. So this is definitely a rich area. So let's get started with maybe maybe lambda functions would be the right place to start, because I think there's the definition of square n is really lambda n goes to the right hand side, and if you've got multiple arguments, it's lambda this goes to lambda that goes to lambda the other. You're allowed to curry arguments in Swift, which means you can pass some but not all of the arguments. So hypotenuse AB, I could say hypotenuse 3, and that creates a new function that takes AB and calls hypotenuse 3 with B. Is perfectly legal for Elm. Okay, so a square equals, well, if you did square n equals something. All right, so let's see. The story is function definitions with arguments, and I think a story is lambda expressions. Okay, and we had, yeah, so how does square n equals n squared? So I think what's going on, well, let's define it. Okay, so my square n equals n squared. Okay, it returns a function which I think is lambda n goes to n squared, and when I call my square with 3, it passes that in. Oh boy, so 3 can be there. 3 means, yeah, I don't know. It's gonna be tricky. So I believe what happens is it says, it looks up my square. It says my square's definition is lambda n goes to n squared. Evaluate lambda n goes to n squared with 3. Okay, so just a function application kind of thing. And 3 says, okay, that says lambda n says give me 3, and I'll plug that in everywhere n is used in my expression. So I have 3 squared, which values to 9. But I'm getting confused on the parsing again. If I say my square, then I really have a function name. I mean, it is a reference. I'm not saying my square, but yeah, this is where I'm confused. So if I say let x equal 5, oh, I can't say let. You got to write Elm for Elm. Okay, if I say x equals 5 and I do my square of x, all right, so much for my theory that I'm defining a new thing. I'm not at this point. And so I feel like there may be some smarts going on where it says, oh, I know my square, I've defined that already. That's a function up there. Or maybe not. I don't know, but I can do this, get 25. So from the parsing point of view, like, how do I know my square x is going to have an equals or not? You know, if it has an equals, I think I can do this. My square x equals x plus x. It's a wrong implementation, but no. Okay. The name x. Okay, now I'm worried about shadowing. Name x is defined as 5. Okay, so apparently in the arguments, it knows you can't. Okay, this shadowing is apparently it's legal but stupid. If you use a predefined variable as one of your function arguments, it says like, oh, that really seems foolish. Okay. And more to the unfortunate side of things, I do not know of a formal like definition of how functions evaluate in Elm. I haven't run across that. People kind of go like, well, go see what the compiler does. It's open source. You can look. It's like, oh, I'd kind of like a formal language definition. Thanks. But I'm using my intuition of what I know from other languages that work this way, and that they have this nested kind of definition thing and so on. But I'm pretty sure we want square n equals something to turn into a function, a lambda expression, which is a function. So let's go down that path. Lambda expressions, function definitions as arguments, story function evaluation, a function call. Let's say that. Okay. I think if we can do those three things, we've dealt with the hard stuff in this interpreter. Records have their own little quirks, and we have list types and whatever. They're all things we got to work with. All right. So a lambda expression, which they don't really call out, I don't think, but somewhere they used it. Here, yeah. So lambda n goes to lambda n squared. We don't have a lambda parser, and we don't have an arrow parser yet. Okay. Let's play around with that one a little bit. Okay, so if I say lambda n goes to n squared, I should get function, yes. Okay, if I say lambda n goes to n squared, evaluate with 3, get 9. Okay, so that's a function expression getting evaluated. Substitute 3 for n in this expression, and it should all just work. 3 can't change its value, and that's why this referential transparency idea that I can just copy these things in, it may not be the most efficient way, but if it's legit, I can just copy in these expressions. Nobody's ever changing an expression. It's all, brand new values every time. They're all kind of like value object-ish. Okay. Yeah. So lambda n. Okay. My next question was, can I say lambda space n goes to n squared? Yes. Lambda space n goes to n plus n. Evaluated with 4. Okay. So this is a kind of an independent operator. I think the arrow maybe is not that way. Minus greater n squared. Yeah, it doesn't know what's going on. Okay. All right. So let's define. So for this, we need a lambda token, and we need an arrow token. Okay. Let's see. So tokens, I'm going to close all this again. And let's make sure I checked in, because I get bad about that sometimes. Okay. Should get nothing. And junk. Yeah. Okay. All right. So, and this is where I'm kind of stacking things, because, I could start off with lambda n goes to n squared. It's, I know I'm going to have to stop and go like, oh, well, I have to parse it. And, oh, I can't parse it because I don't know lambdas. So instead, I'm going to use my power of foresight and look at the lambda types. Okay, so interpreter, and we want parser because it's lexer tests. Okay, and this test lambda. We'll check the token, just a backslash, and we expect token.lambda. All right, and this should fail. Oh, yeah, well, it doesn't. doesn't know what I'm, oh, I got to put a, but it still won't know this one. Token int float. Okay, let's put a lambda down here. Now, is anybody going to complain? I mean, the fact is, to me, this function evaluation piece is kind of the beautiful part of this. You know, the way it organizes the symbol table and then has stuff in and can substitute it. It's like that's kind of like a miracle occurs. But we're trying to peel it apart, and I'm pretty sure I can make something coherent, but we've got to make it coherent and conform to Elm. Okay, lambda is not equal to unexpected character because we weren't looking for the less than sign. Okay. I think we'll put it nearer the operators. Okay, we'll just make a name for it. And it's going to be very similar to this. We might be able to find a way to make these things more identical. Input and return lambda. Okay. Okay, good. And then, all right, so we'll add lambda operator. Lexical analysis, which is character level. All right, this one's a little trickier. Test arrow. And that's this. Goes to token.arrow. And we know we got to go over here. Okay, should fail. Now this one, the minus sign, we've assumed minus is part of your comments. Minus, minus. All right. Arrow is not equal to, yeah, expected minus after minus for end of line comment. All right. Because we're doing this incrementally, you know, if it didn't match exactly what we're looking for, which up here is end of line comments, we get this situation. You had less than, greater than, or dash greater than, and it's like, no. All right. And I think that'll be where we get today. Let's see. So we got a case, and here's minus or end of line comment. And I'm going to make it, I don't know, I'm going to say minus arrow or end of line. Rename. Okay, well, let's go down in there. Okay, so if the character is a dash, we come in with a dash, so there's our first dash. If the next thing is a dash, then we are in an end of line comment, and we keep going until we get a new line or an end of file. Okay, but if the character is a greater than, this isn't going to be too bad actually. All right, we consumed the minus. Now we need to consume the greater than. And we will return token.arrow. Okay, so we had the minus, we consume it. We have the greater than, consume it. Got arrow, and now we're sitting on the next character. This should pass. And we don't have to worry about the other paths, because if you got that greater than, we know it's an arrow, you return. Otherwise, we treat it just like we used to. All right. Things go in pretty easily, you know, when it doesn't break anything. The model holds. All right, so this is the lexical analysis model is 99% equivalent to regular expressions. For us, that extra 1%, and maybe it's more, is the fact that you can have nestable comments in Elm. You can have brace dash bunch of stuff, brace dash again. Now you've opened up a new nested comment. You go on until you get a dash brace that closes the first one, and then dash brace closes the next one. So if you nest them, that's no longer a regular expression because you can have arbitrary depth, so you can't express it in a finite number of nodes. And you have to have memory, a stack basically, to count things. So it's kind of a fundamental result from language theory that says regular expressions and finite state machines are equivalent, and deterministic and non-deterministic are equivalent. They all can parse the same stuff. But if you want to do stacks, it's out of range of any of those three, unless you start extending it like we did. All right, so we added arrow operator for lexical analysis. Okay, so the lexical analysis is down there at basically regular expression level. The parser is up there at a level where it handles recursion, and recursion or a stack is enough to let you handle nested parentheses and match them up. And if you're doing braces or parentheses or nested comments or whatever nests, you've got to have something at least that sophisticated. All right, so we're out of the lexer and into the parser. So the parser, and here we are, we're in this mess of a variable name thing. Okay, because it's so much is there. Okay, so now we're saying, oh, well, no, this is lambda. So we're doing lambda. That's easier because we don't do anything with it yet. All right, so a lambda is a kind of expression int float uppercase. I think it's let's make it a separate case though. Okay, so let's find our parser tests. Lambda expression. And I think we'll just kind of lay out a test and call it a day. So the expression is lambda n goes to n. Let's call it lambda id goes to id. Okay, so since we don't have operators, it makes it hard. All right, and then we need to say what it's going to be. I think it's going to be a lambda expression, which is a new thing for us. And I guess it's going to be id and variable id. Okay, so the id on the second one is the right hand side, and the first one's the left hand side. Okay, so we're just stripping out the syntax, and we don't have a lambda expression. But I think this is a good place to stop. So the next time is tomorrow morning, Wednesday, 9 to 11:30 a.m., which I know is equal early for West Coasters, 9 to 11:30 a.m., and we will pick up with lambda expressions here. So that's all Eastern time, 9 to 11:30 a.m. And if you missed the episode and you want to catch up, they're on YouTube a couple of weeks later. They're actually on Twitch immediately afterwards. So if you wanted to come in tomorrow afternoon and look at it, you could. And then I do a little bit of editing and put them on YouTube a couple weeks behind. But anyway, thanks for joining me, especially new people today. And I will catch you in the future. And I think we're going to be doing functions for a while here. This is a few episodes worth of stuff, especially if we start getting in these matching kind of things, like the parameters and stuff. All right. Yeah. Code Wrangler. See you tomorrow, and others see you tomorrow or another time. Thanks a lot. Bye-bye.